Welcome everyone to our YouTube series, Test Prep Made Easy. So in this particular series, we are going to post regularly questions on our YouTube channel. The questions may pertain to CAT preparation, maybe pertaining to GMAT preparation, as well as of various topics which are tested in these particular exams. For example, quants, LRDI, English, and various areas which are tested. And each day we will handle certain number of questions and their video solutions. The best approach is to these questions in these videos. So have a happy preparation ahead and enjoy the video. Thank you.
All right, so these are the questions that we are going to try in today's video. If you have tried it already from the thumbnail, good enough. If you haven't, you can pause the video at this point and try it once before you look into the solutions. We recommend you doing that. But if you just want to enjoy the solution, that's also good enough. And go ahead and watch the solutions now. Okay, so it's a very basic idea-based question on geometrical counting. So first, let me quickly draw the chessboard here. What we have is, so in this 8x8 chessboard, the first thing you have to understand is how many squares you have. Now, when we generally ask this question, we don't mean the small squares or the smallest squares out here. So I'm not asking for how many squares of this dimension are present in the chessboard. So just break it down into units. I mean, this is the fastest way to approach this. So consider the 1 cross 1 unit squares. So if you consider 1 cross 1 unit, there are 8 in a row. And similarly, there are 8 in a column as well. So the 1 cross 1 unit squares are a total of 8 squares, 8 into 8, 8 in a row, 8 in a column, right? Similarly, if you consider a 2 cross 2 unit, so let's say squares like this. Now don't count 4 of this. I mean, that is a mistake that people generally make. When you're visualizing, just remove this. Now think about the next one. So next one will be this one, right? So similarly, you can just figure out in a row. So then in a row, you'll find there are a total of 7 squares. Now there's actually a fast way to do this. I hope that whoever is watching the video is aware of coordinate planes. So if you just map it in this manner, now in order to have a 1 cross 1 unit, think about what are the intervals possible with you. 0, 1, 1, 2, 2, 3, 4, 5, 5, 6, 7, all of these, right? So there are total of 8 spaces between these 9 numbers, right? So that gives us 8 square in a row, obviously 8 in a column, hence 8 square. So now if you think about a 2 cross 2 unit in this manner, so 2 cross 2 unit, you need to have a 0, 2, right? That is the first thing. What will be the last thing? It will be 6 to 8, isn't it? That will be the 2 dimension. So think about the starting point. So in this group, we have counted from 0 to 2, right? And here we have counted from 6 to 8. So think about 0 to 6. So 0 to 6, how many possibilities are those? There are 7 possibilities. So obviously you'll have 7 squares on this row, and similarly 7 squares on the column, each column, that is. So total of 7 square number of squares. Same thing with 3 cross 3. The first one will start counting from 0 to 3. The last one will happen from 5 to 8. So 0 to 5, just counted in this way. 0 to 5, there are 6 possibilities. So 6 squares on the row and 6 on the column, right? And 4 cross 4, the one we are looking for, will be similarly 5 square, just dimensional. I hope now you can see this pattern also emerging. And then finally a 1 cross 1 unit, the biggest square out here on the chessboard is this one, right? So that's just 1 square, or 1 square, you can write it. So as in any probability question, you will be looking for total outcomes and favorable outcomes, right? So this added everything is the total outcomes. So all of these added are the total outcomes, and this single spot is the favorable outcomes, because that is what we are looking for. The randomly selected square is of size 4 cross 4, and there are these many of those. So if you add this up, use summation formula or anything you want. You can use 8 into 9 into 17. That is a summation of 1 square to 8 square. Just 8, next number 9, and then just add this 8 and 9. So get this 17. So 8 into 9 into 17 divided by 6, that will give you 204. So there are 204 total squares, out of which the favorable are 25 squares. So the required probability will be favorable outcomes upon total outcomes, which is option A. So pretty straightforward question. If you understand these ideas, it becomes very, very easy to get the correct answer in with let's say 5 second or 10 second. I mean, but any which way, that's all for this problem. I hope you enjoyed it and understood everything regarding it. All right. In this question, we have this M. It's mentioned to be a 10-digit natural number, where this X and Y are single digits at the thousands and the millions position. So basically, this X and Y are the position. So this is the thousand position of this number, and this is the millions. Millions position of this number. Great. How many values can X plus Y take for which M is a multiple of 48? Okay, so these type of questions are very relevant when it comes to number theory. So these are the basic things they are testing for. So whenever you're looking for a divisibility of 48, so 48, just break it into the co-prime parts. What I mean by that is separate the prime factors and then write it in the composite form. So basically 2 to the power 4 into 3 you can do by successive division, or if you have a bit of practice, you will understand what I'm doing here. So 16 is the 2 to the power 4 here. I've just broken it into co-prime parts, right? The 16 and 3 are co-prime to each other. So the idea is for this number, so let me rewrite this 728 y 15 x 324. Oh, there's a trap out here. Okay. But anyhow, I just discussed whatever I noticed. So this thing has to be divisible by both 16 and 3 in order for this M to be divisible by 16 into 3, that is 48. I mean, not necessarily 16 into 3, the LCM of 16 and 3. But because they're co-prime, the LCM is the product. So that's what you need to do. So this has to be divisible by 16, 1, and divisible by 3. So you need to understand those basic divisibility rules. The way we have discussed, you just have to remember 3 types. And we'll also explain the rationale behind those. So the 3 types are 10 to the power n, 10 to the power n minus 1, and 10 to the power n plus 1. So these 3 types are absolutely fine. You can cover every divisibility in this thing. So 16, for example, I'm not going into details, but I'll explain what it is. So divisibility by 16, 16 is 2 to the power 4, right? So for 2 to the power 4, all you have to do is check the last 4 digits. That should be divisible by 16 for the entire number to be divisible by 16. That is the idea. Now, the thing that I observed was for this thing, see, if you notice the last 4 digits, we have this x324, right? Now, x is missing because that is not given to us. But I noticed this 324, that is present, right? So if you think about 2 cube, it has to be the last 3 digits, right? So that is the parity. I mean, I'm not going to why so because that will take a bit of time. I have discussed these kind of things in our lessons. So in this case, if you check the last 3 digits, they are known to us, right? So instead of focusing on 2 to the power 4, I'm focusing on 2 cube, because what you have to understand is a number which is not divisible by 2 cube can never be divisible by 2 to the power 4, right? So this is what I noticed, that this 324 is actually not divisible by 8. What did I write? Okay, divisible by 8. So this 324 is not divisible by 8, implying this M is not divisible by 8. Now, if a number is not divisible by 8, how can it be divisible by 16 any which way? There's an easier way to think this as well, and that is 16 itself is a multiple of 8. So if a number is not a multiple of 8, it can never be a multiple of 16. That is not possible. The other way around is possible. A number may be may not be multiple of 16, but may be multiple of 8. That is possible. But if it is a if it is not a multiple of 8, it cannot be a multiple of 16. Vice versa, if it is a multiple of 16, it has to be a multiple of 8. You need to understand these basic things. The faster this can happen, the faster you will actually observe these in actual questions as well. So because it cannot be a multiple of 16, whether it is a multiple of 3 or not, it really doesn't matter. Again, the same logic, because it is not a multiple of 16, it cannot be a multiple of 48, because same idea. I hope you can see it now. 48 is a multiple of 16, right? So basically there are no numbers which follows this particular property, no number of this form, that is. So that is this question. I mean, it's a pretty standard one. I mean, these type with traps also, with the trap that was there here, also appear in various exams. I hope this was understood. If you are interested to know the divisibility rules in a way that you don't have to mug up at all, you can definitely check our capsule relevant to it. It will give you a very good idea about these divisibility rules without mugging up anything at all. It's just visualization, that nothing more than that. But yeah, that's all for this problem from my side. Hopefully everything was understood. All right, so here we have these three boys participating in a dartboard competition, and the respective probabilities of hitting the bullseye are given to us. Now, the question is looking for what is the probability that at most anything. Now, let us pause here for a moment, because in our classes I've explained this. Those who have not done classes with me, whenever you encounter this at most or at least kind of thing, at least for one moment, just think about the complementary idea, because most of the time it is actually very helpful. So if you look at this, we are looking for at most two of them hit the. So just imagine this. I mean, this is the best example for whatever I was saying. There are three people, right? So what are the possible cases? No one hits the bullseye. So I'm just writing this as BE, bullseye. One person or one boy, right? So one boy hits the bullseye. Two boys hit the bullseye, and three boys hit the bullseye. I mean, you cannot have anything apart from this, right? Because the concern is among three boys. The context is within three boys. So if at most two of them hitting the bullseye is allowed, so this is the entire allowable, domain, right? So these are the allowable cases. So the only thing that is not allowed is this, isn't it? So this is what happens if you understand the complementary idea, because you know there are a total of three people. As soon as the question is looking for at most two, in your mind it should automatically visualize. You should always visualize it something like this: at most two is less than equal to two, because three we can anyhow go up to three. So less than equal to two is everything apart from three, right? So initially, while reading the statement, you should understand, more specifically this question, you should immediately understand is the required probability, whatever probability we are looking for, is one minus this case, right? Where all the boys hit the bullseye, and all the boys hitting the bullseye is simple, right? So 2 by 3 into 5 by 7 into 3 by 8, just correspondingly multiply the respective probabilities. I mean, why so? I'm not going into this video. We have discussed in our lessons. So this is coming out to be what? 5 by 28. So 1 minus 5 by 28 will be 23 upon 28 as our answer, option A. You have to understand this idea. Whenever at most and at least is given in the question, at least for a minute, just think what happens to the complementary. If there are less cases to count in complementary, always count that. That's the general rule. So here, as you can see, there are three cases in allowable one and one in the not allowed. If there are less cases in not allowed, I'll always think about the not allowed. If there are equal, I always go for the allowable one, because I just don't want to do the extra one minus unnecessarily. So yeah, that is what I tend to do. Pretty straightforward question, hardly a 5 to 10 second problem if you understand, I mean, after reading in this context. So yeah, that's all I had to add. Thank you for joining in. Well, we have a question in which we're looking for the number of factors of something. So I was first looking at this part, find the number of factors of n square. Now, the initial premise is talking about n is a number having exactly 7 factors. Oh, pretty standard. So in these type of questions, you have to understand the one basic idea of number of factors. So I'll just explain that, because anyhow, this question is hardly a 5 second explanation thing. So you have, let's say, a number of this form. The number of factors of this n. So let me write this in short. This is typically what I do in our classes also. So whenever I write this, just read it as number of factors. So number of factors of n will be given by. So just check this out. For p to the power a, again, consider that p, q, r are all distinct prime factors, prime numbers or something. So these are all distinct prime numbers. So for p to the power a, all the factors will be ranging from p to the power 0 to p to the power a, right? So there will be a plus 1 possibility, this one because of p to the power 0. And corresponding to that, this will have 0 to b, that is b plus 1 possibility. So number of factors is given by something like this. This is the basic idea of using number of factors. Now, in the question, it tells us that the number of factors of this n in the question is 7, right? Now, just think about this for a while. You can't split 7 into something like this, right? Yes, you can do 7 into 1 into 1, but in that case, I mean, b plus 1 will be 1, so b will be 0. And whenever you place a power of a prime as 0, that power, that prime is not present, right? So effectively, what you need to have is, I mean, this number should be of this form p to the power a. I mean, there will not be multiple prime factors. That is what I meant to say. So each of these parts, give us different prime factors here, right? So because 7 cannot be split further, so it has to be allocated to any one of them. I don't ponder on a and b, by the way. It really doesn't matter. The context is that this number n has to be of the form some prime number raised to 6. So when I write p, I don't care about this p, by the way. It's just a prime number p. Okay, so this is what the n is looking like. So same idea, n square will be square of this, so that is p to the power 12, right? And just use this reverse idea, so or the direct one in this case. So p to the power 12 will have 12 plus 1, because p is a single prime number, so we can do that. We already have that. So p to the power 12 will have 12 plus 1, that is 13 factors. So pretty straightforward question. I mean, I've discussed, I mean, humongous number of variations of related to number of factors. Some really good ones as well, based on previous CAT sets and all. So yeah, you can definitely check them out. But yes, that's all I had to add for this question. I hope everything was understood.
Hopefully you liked the solutions we provided for these questions. And if you did like it, do not forget to like the video and share, subscribe, and comment. Do subscribe to the channel and click on the bell icon. In that case, you'll get notification as soon as we upload a new video. And if you want to check a bouquet of courses that we provide, so we have a huge variant of courses from customizability to full preparation. You can check our website www.mathoratory.com. I'll leave the link in the description below. And have an enjoyable preparation ahead. Welcome to the Mathoratory family and have a good exam ahead.